Yo. Figured I'd come back online. I did mention that earlier. And this button. Maybe right on the stream. Looks good. I mean, it does impact how bright I am, but I can turn it. There. Now I'm not blinded on the side there. Anyways, okay, so we're back online. Something I'm debating is there's this large scaffolding requirement. Okay. For the whole networking layer. And honestly, the majority of it, I just don't care about. Like, even these aliases for these defines, I'm going to probably go ahead and essentially write a new nel inclusion. I don't know if I want to put it in shared or not, though. Let me start by just putting it in server. Arguably, though, because like client uses nel as well, right? Yeah. Does it have the weird, like, nel miss commands? Yep. And does it also have the funky main? No. Okay. Makes sense because it's more of a client, so it doesn't need all that crap. Let's just call it network service for now. And it'll be similar to the scaffolding of login service to start. So instead of calling it storage, we'll call it like a message. And one of the integrations will just be called nel. So network service was just included. We're going to basically strip out all of the integrations for now. This is actually going to be the message DB. Probably going to rename that, but we'll start with that. Okay. Storage should be message, or I think so. And then this, I'm gonna need now instead of memory. And then this, honestly gonna be a dummy file for now. We're calling this shard memory. Honestly, we gotta wait a bit before we fully scaffold this out. What's our latest error? Add subdirectory message. And it's just that it's old files. Okay. So what this network service is all about really is we're gonna dumb down the listener and the general binding that allows you to get messages. So like port and the request types. Yeah, we include message. Message is called message.db. That is being included properly. Word message.db is bad, but we're going to keep that for now. And so now is going to need message.db as well. We don't need the domain declaration. Shard.db is the implementation. So and then all the integrations for now are gone. We'll keep the mux, the mutex, and we'll rename shard memory to, we don't know what this is called yet, but we're going to call it like nail message or something. Technically, yeah, whatever. We're not worrying about it right now. So message.db can't be included. I think that's just a old make problem. We'll see if we can get it to compile. Even with that, it's just a stub for now. And ultimately, I'm going to probably abstract out logging as well at some point. But messaging is a component that will likely be passed around as just the network service. And yeah. So let's see if this compiles. And if it does, we're essentially going to try to figure out and nail all the different bindings that are required. Yeah, it compiled, no problem. Even though this is still telling me that it can't find the message DB, it can. It's just like a relative directory problem, which is weird that CMake is failing like that. But doesn't matter. We can ignore it for now. All right, so next. Let's make a command that literally just starts it. probably just connect. And you're going to need like host port. Theoretically. Wait. This is ShardDB, which integrates storage. No. This is Nel, which is the equivalent of this. So closer to that. And then for the integration, yeah. Now we have a Nel lib message Nel that integrates. Wow, there's a lot of messages going on my. One sec. Okay. So the next goal is we need to figure out how to do a connection dial, pretty much in the style of what currently is happening. It's likely in shared. We search for all the port usages. Ooh, there's gonna be a lot. The fastest way we're gonna find it. Probably we go to login. We followed the def. We can see it calls main with a service port. That's not the right main. I don't even know which one's the right main. This is part of what I don't like about all this. It's like, it's just not mapped very cleanly. All these abstract macros and defines and weird stuff. I know it's an iService. So maybe what I should do instead is iService. Does this define a main? Yes. So service CPP main. All right. So this is essentially what starts the whole process. I'm probably going to rewrite the whole logger system as well. Yeah. It's so like embedded. I don't like it. All right. Wow, look at this. There's all these parameters for like UI setup, which all goes away because I'm focusing on Linux now. Init signal. So honestly, I need to like bookmark this or keep this over here for reference. Because eventually this will do port initialization. Okay, so like init network. This is calling s initialized on Linux. Calling a load with order relaxed. just so convoluted. It's like a pain in the butt to even follow the logic. I think this may be the call though. Let's do this. We're going to open this file up, but we're going to keep going down to see if there's another actual dialer or if that's all we get. Yeah, there's just so much. Add network association. Normal setup for the common services. Naming service address. Honestly, I might bypass the naming service because it's part of the ecosystem. We have like cross-contamination with like the unified network that everything calls, or this, which is the use connection. I think it's iterating all the connections because they've been unified to ultimately flush them. Then we add the callback arrays for all the service callbacks. And then we have all these path setups. Here's the actual connect call, which is actually in unified. So sock, what is sock doing? It's doing this S initialized. But then there's initialized. What is S? And then there's a thread check. And it has service list. Iterate all the services. The services, the shard ID is not equal to ours. Then add it as a new connection. We put the last true because the name callback should already inserted it by unit registrar. Okay. And so what is add service really doing? Is this actually doing the dial, or are we still just in the more thread checks, find if it's external again, do a unified connection creation here, set the state to not used. Set a bool to if it's true, if it has connected, resize the number of connections by 1. Okay. And then we do a cleanup disconnect. Then with CVC, we actually call the connect. See how much like junk is in here? Then we have an identity registration call. Then this ultimately is calling this, which is then calling this. And then it ultimately creates a thread. Oh my gosh, this code is just like, how many layers of function calls have I gone through just to find the actual connection? And we still haven't truly found it. We're just finding like an abstracted layer over an extracted layer over an extracted layer. But then ultimately, we need to make a note about this. See, to me, what I kind of imagine that each connection would leverage network service. Network service wraps each connection individually. It handles all the threading and mutex and all that fun stuff. And ultimately, hey, Darius, doing it this way just makes it easier to like visualize and also just instantiate, have the service itself do keep alive management and all that crap, and abstract it out. The reason you want to abstract it out then is if we integrate like gRPC or something else, there's no like hard-coded headaches like this thing is doing. Because this basically has an array of connections that it's subscribing to with a predefined list of callbacks for ultimately seeing a publication. Even the serializer, I bet I could clean up. Oh, look, we finally found the sock. So csock has the connect call. But can I find all integrations of this? So like login client does a raw connection like this, but then the unified server Look at all this code. That's an interesting design. This is just verifying all of them got connected whenever you add the service. But where's the actual connect call? I think it's up here. Yeah. So CBC attempts to connect. And when CBC does it, it calls cbuff client. Cbuff client uses inet host, which is just a wrapper around the port and the host name. Okay. So then we have buffsock, which is a non-blocking based on cbuffsock. And cbuffsock uses a TCP sock, which uses csock. You know, because if you don't have like 7 inheritances, I mean, are you really doing it right? Okay. So now that we can connect with csock, honestly, I should just be looking at what actually is doing net. Like inet address calls winsock or sockets. Inet, this is all part of the inet address stuff. That makes sense. But see here, we have some socket stuff. eSocket, socket error. What are the methods in this function? I think this is closer to the raw. This is really close. In fact, I think this is actually the integration. Okay, so at the end of the day, will this even just do it? What's up with these? No. This might work. It's attempting to do a socket creation. See, this is using sock dgram. I don't think that's compatible. Where's sock dgram declared? Those are socket types. And technically, we can probably include these. Get some of these. I don't know where socket FD comes from. It's just an int. I think this is just a local property it's trying to do. The next question is, let me ask it some questions real quick about pretty sure socket FD is the pointer to the socket connection. Probably just call it con. Guess another thing, oops, we closed all those, but actually we want to keep this open. I mean, a datagram is going to be more low level. Address family for IPv4. Sock stream is a TCP connection, while sock diagram is UDP. And then iproto UDP is a constant. So it's using a UDP connection is really what that all translates to. I'm pretty sure. Probably be a couple changes needed for it. Okay. So not soccer FD, add socket FD, and it should figure out the type for me, right? Is it just an int? I don't know why it's doing it with the weird -1 start. I mean, I guess that's right for initializer. All right, so this now should do a UDP connection. Double check it compiles. Yeah, it's all happy. All right, so now let's create a listen. I like close. You're not just going to autocomplete it for me? You know, you got one damn job, Copilot. I don't care about saving it all because you come right back every time. All right. Did I fix you, Copilot? Thank you. That's all I want. Just autocomplete my shit for me. All right. So. Yep. Yep. Yeah. We could add interface support later, but I would assume for the interim, you just want it on 000 for listening. Technically, you don't need to specify a port. Let's actually do that. That's better. Okay. I don't need the word failed. Also, yeah, that's better. So this lets me do error wrapping. And so when it goes up the stack, you get this nice string-based return. All right. Okay. So now we need to make a thread pool to listen as it's going to be something like pull loop. How about like pull messages? You gonna figure it out? Yeah. So it spins up a lock. Socket's not open. Can be an include on the top. It's missing. What else? Another question. I don't think it will, but I want to see if it detects any issues with that. You lock the mutex, create a socket, and start the polling thread, then release the lock when listen returns. The polling thread calls, which locks the mutex independently. The mutex is only held by one thread at a time, and there's no recursive locking or waiting for another lock inside. Yeah, okay. Just was a little nervous with how that code was. I know threads aren't the cleanest, but I kind of like this design. It's really simple to follow. You have a lock, the lock calls, it does pull messages. One issue though is the buffer. Is this a bad design with pull messages? Since the thread can be locked with the mutex waiting for a message. I think it would. The pulling thread acquires mutex and waits for receive form to return. If another thread tries to call a method that also locks mutex, it will block until it releases. If receive form is blocking, this can delay other operations. Yep. If receive form blocks for a long time, other threads may be blocked. This can make shutdown or other sockets slow and responsive. Minimize the locked region. Only lock the mutex for short critical sections. Yeah. You know, that's interesting because you're writing blocks for every areas that you're doing locks. And then once you have the lock, I just do a quick message check. Yep. That's clean. I like it. It's kind of like a quick lock. The code isn't too hard to read either. Cool. So, what we're going to need to do now, and I'm already an hour in, geez, is we need to now establish a the different layers of receiving the message and doing all the handling of it. But technically we call this network service, but it does both client and server servicing, I guess you could say. But that makes sense because you have a listener that's going to receive messages and you have a sender that's going to send messages. And each of these services should be representing individual connections. Where this gets a little weird is there will be scenarios where the same service will be listening and connecting to itself. But there's no real inherent problem with that because they're all different threads. They all have, it's just going to be a different callback origin. Instead of cross-process, it'll be the same machine. I don't think that's a big deal. Another issue is I kind of said I was going to do this anyways, but I'm painting myself into a corner with the fact that I'm writing this exclusively for Unix. I might have to write some layers of extraction later if I want Windows. The only problem with Windows is with the client, if I use the same service in the client eventually. But there's nothing stopping me from just keeping the client vanilla for now. You know, and just make it compatible with it with my new layering on server. Okay. So the next thing is we need to create the callback service and the marshaller. Because we, in theory, can now create a connection. For fun, we can test it real fast. So in login, in all of its messiness, we have We're going to call this, I don't know. So network service message nel, that should be the required includes. That'll get network service declared. And so now we just got to find instances of login service. I think there's like an extern inside of here. Oh, what did we call it? Net listener. And what we would do is just say, yeah. It would actually be connect. And the host can be, oh, actually, no, it's going to be listen. The host can be empty, and the service port will be like, I don't know, 8191, sure. The other thing we'd probably want to do, this is just temporary, so we're just going to call this like net connector. You're going to give me complete? I don't get why ChatGPT is being so slow sometimes. Like, look at this. It should be instant. And it's a super easy ask. If net connect result, then NL error, failed to connect network. Net connect result error C string. You have a really long chat. It doesn't matter. Like my autocomplete just starts crapping out sometimes. I don't really get why. Honestly, I think I need to restart my remote server. I think it's starting to like lag in weird ways. Because I mean, you can see all these instances I got spun up and stuff. The CPU usage is like minimum though. And while it has a ton of cached memory, I don't think any of it would make it run that bad. Anyways, theoretically, we now have two connections going to happen. Hit build. Have to build everything again. Oh, network service is not found in login.h. Why is network service not found? Network service is included here, right by login service. No such file or directory. I might need to rebuild my config. No. Can't find network service.h. So we take the current directory, we go up 3, then we go down to network service. We include this header file. I do know it's failing on this line. Is that? I don't think that's related. So you can find config service, no problem. And you can find login service. Is network service unique? Yeah. Honestly, I'm going to just do a make clean. This could be a cache problem. It happens. Nope, it's still unhappy. Why are you unhappy with network service? Network service is named correctly. Network service includes properly. Well, if we take it out temporarily, does everything else compile fine? Pretty sure we could potentially include this, by the way, as like this as well. What do you mean expected a file name? What is this? Chopped liver? Can't find network service H. Oh, we have another failure though. That's good to know. Oh, pull thread was not declared in this scope. Pull thread should be in the... Why is this isn't working? Oh, I didn't have the include for thread. Cool. So we compile fine. It's just that when we include it, we're having some other issue. But let's see if this fixes it now that we have the... Nope. It doesn't even like the include. So let's just double check that. Yeah, see, we're still failing to even find the source file. which suggests that I'm messing up this include directories. Ah, that'll do it. I'm pretty sure that's the whole reason. Hey, there should be a network service declaration above it. Yeah. That's right. I called it net listener is why. Why are you taking forever? All right. What's our next error? Network service. Don't know why you're failing. Why is message DB considered uninitialized? Oh, well, first of all, that's wrong. And that might even be the real reason. Getting farther. That could have been it. What I'll probably do next is some sort of like raw send method and just send data to the net listener and see if I can just send a message and print it out. And there's like the most rudimentary starter socket connection. Oh, we got an error. No version. Oh, that's right. Auto network DB. Isn't that how we're usually initializing it? Where is the login service? Networks login service, shard memory. Oh, we just gotta go find shard memory actually. And just make a static of I think it's just called like nel message. Isn't that what it's called? Shard memory is a header file. I need to call it nel message or something. Technically, it should be message nel. This might require a CMake build because I renamed files. Sometimes CMake doesn't do great with that. Anyways, that gives that instance. And both of these need nel message. I think I can just share the same instance. No. I honestly shouldn't make nel message maintain the connection. The problem though is that if network service manages the connection, it gets a little tacky. Okay, what's the next error? Network service is supposed to have a constructor on it, which is message. Technically, this should be message DB. I don't know why it's called message only. That's probably why we're getting errors. And okay, so this is happier. Now we got net listener, but it's failing with network service has no method called listen. Did I not bind it properly? Yeah. What I need to do is take you and take maybe you, and essentially I think they're like identical. They just don't need the zeros. The implementation has to be done as well. There we go. Yeah, more, come on. There we go. See, that's how it's supposed to be. A lot of my scaffolding is not very complicated. Okay, so listen is now working. The port is a integer. Okay, what's the next error? Extra token in the include directive. Oh. Okay. Next is it doesn't like those are just warnings though. The no discard is ignored. Why is it being ignored? Nel.nlcp not found. Where is nlcpp? That's a combine. That's a compiler error. We may have to run cmake config again. That's like a linker error. We're getting close. So basically, what I just wrote is a really basic UDP socket connection and listener. Low level, bare bones. And I will start incorporating all the Nel messaging layers on top of that. And it'll be a lot simpler. I'll have a per service manager. And I need to get as many guards and logic pieces out of the main Nel system. And into the the network service. But I don't know if I'll be able to do that very cleanly. All right, what's our new error? We still include Nel H. We need this to be Nel message. Okay. We still have a no discard warning. Where is it ignored? They're trying to imply that listen is being discarded. Doesn't look like it is. Whatever. Okay, so we're going to go ahead and run it and just see what happens if we get that message. Okay. Yeah, we're getting a failure about the socket already open, and this is because we are sharing the nail message instance. So this needs to be renamed to like actually nail message is for the listener. So we could even just instantiate something new. Think I can do that? You gonna build and save? Ugh. What do you not like? I can't instantiate it with nail message. Probably a pointer problem. Is there going to be a pointer dereference? I should just use AI to do it. I mean, it worked. Okay, so let's see if this now just connects. Invalid host address is the failure now on failed to connect to network. It doesn't like localhost. Is it like 127? It does. Network connected, question mark? Network connected. Cool. So next is a very basic send command. Something like that. And say, you're going to send it for me? Bytes, send the message data from the size. Okay. And okay, so now we have a receiver. Happy? Fail. We are happy. Okay. Let's see if we get a network connected. One issue is probably need a delay. It's also possible it has a buffer problem. Okay. So, oh wait, yeah, it's not going to work because we're not sending anything yet. I only wrote the ability to. So let's do a net connect, send a raw message. I think that's it. I should do it with autocomplete it for me? Nope. A build. Okay. There you go. So step one is complete at least, which is we have a raw socket connection and a raw dialer. You can see here, I don't see the port being forwarded or at least reported on that, but that's fine. It doesn't really matter right now. Honestly, the hardest part's to come, which is this whole exchange. And I mean, naming service does have the side bonus of doing like remote management of all these different services. So like the, you know, service changes and stuff. But to me, I want to adapt a lot of this logic to be more stateless instead of stateful. And I really want each of the services to just keep alive. And if there's any sort of critical situation, it should just drop it and, you know what I mean, recover it later. I'm okay without that high level of resilience across the stack in exchange for simplifying the stack. Because as we add more features, it can get harder and harder to manage everything if we have this convoluted layer of red tape to do anything, is my opinion. Especially because with this rewrite, I'm now able to hot swap out the whole Nell messaging system. So like this is just me adding legacy support. But when I finish this, I can add a new folder and call it gRPC and redefine all the messaging in proto files and create an entire exchange in gRPC, including the client being able to talk with gRPC. Or I could, you know, write a quick transport mixed with like, you know, cat and proto. Or in Tempo's case, he probably wants to do web transport so that he can have it browser supported. And it'll be a lot easier for him to write native support for it using this sort of integration. Because all he has to do is satisfy this interface. So cool. I'm overall happy with my progress. Not a lot of errors, and it's super easy for me to take this out and put it back in and stuff as I need it. The real question is creating the callback system and having a dispatcher. We kind of have examples of it in here, which is where connect. So when you do CDC send, is this literally just sending a memory stream? It pushes the buffer. And what does pushing the buffer really mean? Some sort of buffer assertion, a lot of commented out code. If the socket's connected, push into the host send queue. Update sending. Why do we have a send queue? Like, why does buff FIFO? Is that just that if you get a bunch of messaging? All right. Get local time, flush. Is flush doing the actual send? It's ready to send the buffer, compute the size, and add it into the beginning of the buffer. Pop it out of the queue. Push it to the front. Why do we have a buffer queue? Why not just send it? Keep it simple. I think this is like some RUDP junk. Ready to send buffer. Or clear the only data that was actually sent. Yeah, I don't really understand why you need a send queue. I'm assuming it's for like reliability. Anyways, I didn't learn much from that whole review. It was literally just that it has a queue buffer and it basically checks if there was a partial send. And if there was, it does some sort of recovery thing, it sounds like. But regardless, we have the receiver would be interesting. We take the socket data and we disconnect it if there's any failure with some, those are actually guards. That's nice. So he does guards and then he does this weird junk. If we're receiving the buffer, take the payload, take the bytes read. Right. But like, why are you making this so convoluted for something kind of rudimentary? I mean, I guess this is part of being able to receive a UDP packet that's larger than the buffer size. Fill socket ID and event type. Push the message into the queue. Comment out a huge chunk of code. If the connection fails, do a catch. Test a wake up pipe. I think this is just lingering 2005 code. Clear the closed connection. Okay. Here's a part I need to wrap my head around a little bit. All right, so we have the net base for callback, which is just an initializer with statistics. Add callback array. This one, I think, is the key thing. Process one message. Uses cmessage, takes the ID, goes in, hits receive. Once it receives the length, we iterate all of our callbacks. Then we call the callback with the message in based on the real ID and the instance. Yeah. So message and receive or process one message, we got to double check. But this also, yeah, this is just the C buffer server. Taking the queue, popping the data. There is, this might be important. I don't know if this is going to be actually in the payload. I think that's what this is implying. Here's some mutex value data points in their atomic system. Trying to receive the queue. All this logic. All right. So typically during the net base, there's a base update based on timing. It processes one message, receives it, does this junk, has a timeout check. And if there's an exit flag, it flips it on there. And then there's another outer loop for update, which is a whole other chunk of code. This is just the polar. I don't know. Huh. Okay. Basically, this doesn't look very convoluted or hard. What we could do as a quick test is take login toml, change the, is it the web port? Man, I don't even know. Because login uses or 99997. I think this, if I change that to my WebSocket or my new UDP connection, I should see the data coming in, and that might give me some hints. I'll have to hex dump it to really understand the data though. But it's enough for now. So we're going to go to login. Take this port, pop it in here temporarily, start the client up. There you go. It's using a different port because it's doing something weird. It's still attempting to connect properly. Service ready, new client connection on 504. That's the local IP. So this isn't the right one. Is it this one? 8191. Oh, wait. I'm doing the wrong file. Client. This needs to change. One thing that's interesting is I don't think it even attempted. That implies that it's a TCP IP address. What's it saying? 8198 connections refused. 8191, sorry. So it is trying to connect to the right IP address. Let's try not using localhost. It could be I'm not binding properly. Oh, wait. Honestly, yeah, okay. Put this. Double check that it fails again or not. It does. I should be able to set this to 000. Or better yet, no. This should be binding to everything. We're fine. But why aren't we getting a connection? This implies it's TCP. Which is weird that I'm getting a UDP connection. I don't think it's very hard to swap it though. But I might stop for now. We hit pretty good progress. We've done a lot of revamping and adding of new code. What did I do to client? I'm going to probably revert this. Change. And I did some other tweaks. They're all good. Anyways, I think I'm done for now. I wrote a pseudo network service UDP listener, and which is great for like foundational start. If I can just wrap and simplify the whole messaging queue into a really dumb service that I can just instantiate anywhere, and then create the callback methods, and then handle them almost identically to what I have now. Even better if I can design contracts that can then be unmarshaled and not necessarily inline serialized like we have currently. That would be massive. But we'll take one day at a time. But at this point, I'm essentially kind of rewriting all the networking. But it'll be dumber. It'll be simpler. It'll be easier to like iterate on and improve. because like shared right now is convoluted. It's got a lot of like safety mechanisms in it, and I understand like all the code has purpose, but it's kind of overkill in my opinion. Keep it simple, you know? Keep it simple and iterate on those foundations. And it's important to keep it simple because my plan in the long run is to use third-party networking service. So for example, use an ingress that's managed by Kubernetes, and or use a networking stack that's managed by like gRPC, so that I don't have the burden of maintaining and doing all those optimizations on the networking stack, which is what the current code is doing, right? It's handling everything. It's orchestrating, it's doing like network reliability, it's doing all this junk. And in modern stacks, you can just abstract that junk away, a lot of it, and then just make a reliable connection, or even just if the connection fails, drop, right? Get yourself out of commission and have a new one come in that's fresh, that can maintain it. And then if you have enough services running, the delegation calls, you know what I mean? It's just going to be whoever receives it. In fact, the whole ingress pipeline could even be where you have 3 different services, blindly connected. And when routing happens, it'll just be based on host name. So, you don't even need what naming service is doing right now and welcome service is doing right now, because ultimately you just connect to a generic port or a generic host name, and you just get the connection as, a service. You don't have to worry about, like managing multiple connections to all these different, all that kind of ecosystem gets abstracted away, is what I'm hoping. So, and the same thing with like gRPC listeners. You can create a connection pool inside of gRPC, and it does all the management. You just have to call the library, and then you don't have to write and maintain all that code. So yes, while I am writing a very simplistic network service right now, that's just for legacy support, and I'll kind of, start scaffolding up a primitive legacy networking. But the end goal is probably converted to something like gRPC, gRPC or anything really, or take the existing and turn it into contracts so that client and server are more in tune with each other. And anyways, lots of talking, but hopefully educational. And we're going to call it. Thank you again for hanging out. And that's my TED Talk. No. Adios.